So the solving process of these is going to be the exact same as it was for when we didn't use a calculator. So when we were solving the trig equations and we didn't have a calculator, then we would get something like the cosine of theta equals negative square root of 3 over 2, right? And then we'd have to know our unit circle values. That's how we get our angles. So here we'll get something like the cosine of theta equals 2/5. And you'll be like, I have no idea what that is, and that's why we need the calculator, okay? So I want you to think about what we do when we're looking for what the angle is if cosine is negative square root of 3 over 2, because we're going to have to do these same kinds of things with our values we get off of our calculator, but obviously a little bit different because they're numbers on a calculator. So if I have, when I talk about the angle, so for instance, if I said, cosine theta equals negative square root of 3 over 2. So the first thing I would do would figure out when is cosine square root of 3 over 2. And I would say, well, that makes that a pi/6 angle. The reason I talk about it like that is because that's the reference angle, right? So pi/6 is my reference angle. And that is always in the first quadrant, and that is alpha, okay? So alpha, this is my reference angle. And alpha, remember, it is a lowercase Greek letter. Looks like a fat Jesus fish. When my handwriting gets bad when I'm writing fast, they look really weird, but that's not even a great alpha. Just know it's not really an A. So I'm thinking pi/6 angle, I want negative square root of 3 over 2. So I know that cosine is negative in the quadrants 2 and 3. So what I would do, and the way I say it to you every time, you may think of it differently, but I think, okay, I'm here, this is 6 pi/6, which is pi, and I would back up 1, and that would give me 5 pi/6. So basically, I took pi and subtracted my reference angle. So this is pi minus alpha. And then I would say, okay, this is 6 pi/6, and I go forward 1 to 7 pi/6. That's because I took pi and I added alpha to it. And then to get this quadrant, I would go to 2 pi, which would be 12 pi/6, and back up 1. So that's where I would get 2 pi minus alpha there. And that's how we're going to come up with those values. Any questions on that right now? All right, so what we know around the unit circle, we know that this is 0 and 2 pi. We know that this is pi. We know that this is pi halves, and we know that this is 3 pi halves. So we need to know a basic estimation of those measurements in decimal form so that we can approximate some things or know what quadrant we're in. So if I said, like, you have the angle is 2.73 radians, you would need to be able to know which quadrant that's in. So I'm not saying that you have to have this stuff memorized. There's just some things that I know you already know. Well, 0 is 0, right? Pi, we should know, is about 3.141 blah, 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 blah. So those are no-brainers right there. So then I'm going to give you the other actual decimal approximations. And obviously, if you're using a calculator, you can figure them out as well. But sometimes it's easier just to kind of think about things and not have to always go look up a decimal. So if this is a little over 3, and this is half of it, this would be a little over 1.5, right? So I think that my 2.7, it's somewhere between that 1.5-ish and 3.1, I'd be in the second quadrant, right? And then if this is this is half of it, so this is this plus half, so I would take my about 1.5 and add it to this, so this would be about 4.6-ish, right? And then if I doubled this, this would be about about 6.2-ish to get over there, and you just can kind of estimate, all right? But if it's real close, let's say it really was 1.5, and you're like, okay, I know I'm estimating 1.5, maybe I need to do pi divided by 2 and look at the decimal so that I really know. But, and see, I don't have these memorized either. That's why I'm going to have you write, but we are just going to write them down. This is 1.570, blah, blah, blah. And this is 4.712, blah, blah, blah. Okay. So I don't have it memorized, but I know enough that I could estimate, and we were a little under our estimations on both of them, but, I mean, that's to be expected because that's what estimating is. Okay, we all okay with all that so far? All right, so here's the key to all of this so that you can get the right answers. We always find alpha first. I don't care what they're asking me for, I'm finding my reference angle. Just like we do with the exact values. The first thing I'm going to do is the hand trick and think, okay, that's a pi sixth angle or a pi thirds angle. Then I'll worry about what quadrant I want to be in. Okay, you're going to do the same thing with your calculator. So this says here to solve each trig equation on the interval. So we have an interval just like we did before. And then it says to the nearest thousandth, that's 3 decimal places. It should also say, because it does on the assignment, and I thought I put it here and I didn't, to the nearest thousandth if it's not a special angle. So if it is square root of 3 over 2 or whatever, then I need it in exact form, not the decimal form. But if it's the ones we don't know, then it's in decimal form. Okay, so let's look at this. I've got 5 sine x plus 1 equals 0. So I'm going to subtract 1 from both sides. 5 sine x equals negative 1. So sine x equals negative 1/5. All right, so here's where if that was a value we knew, we could come up with our angles, but we don't know what it is. So x is going to be equal to the sine inverse of negative 1/5, but do not start punching buttons on your calculator yet. There's a couple of things we got to do first. First of all, no matter what this says, we always use positive numbers in the calculator. All right. So this is what I'm actually looking for, but we're doing the positive numbers because we want to find alpha. Alpha is what we're finding first. And I need to think about the fact that my sine value is negative. So sine is negative in quadrants 2 and 3. No, it's not. What quadrants is it negative in? 3 and 4. I don't know where my brain just went there, but at least I caught myself. 3 and 4, duh. All right, so now when I go to type this in the calculator, even though I have sine inverse of negative 1/5, I'm using a positive 1/5. Whatever device you are using, make sure you're in radian mode. When I pulled up the Desmos calculator, degree was the default, so radians. So I'm going to take the sine inverse of 1 divided by 5, and I'm going to hit enter. And then if you're using this or the Delta Math calculator or a calculator like this, then pay attention to what I'm saying and don't get ahead of me because I'm going to try and make your life easier. I would do things differently if I was using an 84 or something. If I was using an 84 or a calculator like that, then I would store my number now. There's not, even if I can store it here, I don't think it's really an easy thing to do, so I'm not going to do that. So again, just follow along with what I'm actually punching in here because that's going to be important to you. All right, so my alpha is 0.201 about, so this is 0.201 blah, 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 right? So that's alpha, and I'm putting the dot, dot, dot because it goes on forever. I'm not going to round that. I'm not going to punch 0.201 back in my calculator because you never, ever reuse a rounded number. So from that, I'm going to find my my angles that I need. In this quadrant, this is going to be pi plus alpha. In this quadrant, it's 2 pi minus alpha. And that's going to give me my actual x values. So on my calculator, that's alpha. So I'm going to do pi plus the answer, and I'm not hitting enter. And I'll show you why in just a minute. Because if I have an 84 or one of those, if I don't hit enter, I don't see the answer. But on this one, it shows me the answer. So I'm just going to leave it. I have not hit enter. My answer is 3.343. This one I am rounding because it's my answer. 3.343, no dot, 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 because it wouldn't make any sense. Now I need to do 2 pi minus alpha. And so that I don't have to recreate this, since I didn't hit enter, I can backspace out of this and now do 2 pi minus, and I can still use the same answer that's above it, and I didn't have to retype things. Does that make sense? Okay. So that gives me 6.082. 6.082. And those are my two answers. Yes, did I? On Desmos? Mine is just, oh. Okay, I would use the Desmos scientific calculator, not that one. So if you go to desmos.com/scientific, it'll look like what I was using. Because I honestly don't know on that one. There you go. And if you click on the settings and then click that A, it makes it a little bigger and easier, if that helps. Okay, anybody else have issues? That's why I want you punching along with me so you can find that stuff. Okie dokie. Let's look at number 2. So I've got 5 cosine x equals 2 secant x. All right, so I'm going to need to probably, maybe I'm going to need to substitute something, I'm not sure. They're not squared, so I'm not going to do anything with that. But I do know that secant is 1 over cosine. So I will make this 5 cosine x equals 2 over cosine x. So at this point, I'm going to multiply both sides by my denominator so that I get 5 cosine squared x equals 2. Now I want everybody to pause here because we're going to take a little field trip off to the side and talk about some really wrong, bad things that I kept seeing over and over again. And I want to make sure you all understand why you can and can't do certain things. It is totally fine to multiply both sides by that denominator. Not a problem at all. I could divide both sides by cosine x if I needed to. Not a problem. What you cannot do is you cannot completely divide a variable out where it goes away completely, like or my trig function. I can't completely get rid of a sine or cosine by dividing. So, like I said, we're going to take a little side trip here. So let's say that I had 2 sine squared x cosine x equals cosine x. Okay. So if I said, all right, I'm going to divide both sides by cosine x, so that these cancel out and they give me 1, not 0, which I see sometimes too. And then these cancel out, so I get 2 sine squared x. This is a big fat no. No, no, no. I just divided both sides by cosine, and my cosines are now gone. No more. I completely lost some answers. Okay, I've lost some solutions. So this is a big fat no. Instead, this is what should have happened. 2, and because I want you to see how it's different. Sine squared x cosine x equals cosine x. Now, if I'd have had a sine x over here and divided it out, I can't divide out and make them go away. So I'm going to need to try and factor. So I'm going to move this over to the left and get 2 sine squared x cosine x minus cosine x equals 0. And this works. This isn't a trig thing, by the way. This is an algebra thing. So if these were just plain old x's and y's, I couldn't do this either. Okay, so again, not a trig thing. It's an algebra thing, but I saw it enough that, and from people that normally don't struggle with the algebra stuff at all, that I feel like we need to address this. So then I would factor out the GCF. So I get cosine x times 2 sine squared x minus 1. That's why when y'all say, oh, I'm going to divide out this cosine x, I correct you every time and say, no, we're not dividing anything out. We are factoring it out because it is not disappearing. So now when I go to solve this, when I set this equal to 0, I'm going to end up right here where I could have finished here, but I also have cosine x equals 0, and that means I lost 2 solutions by dividing it out. You with me on that? So I wanted to make sure that you understand the difference and why one is okay and why the other isn't. Okay, we can't divide out and make a solution disappear. Okay, all right. And again, in any type of algebraic thing, it's not just solely a trig thing. Okay, so then this one is a yes. All right, so let's go back over here. So now that I'm here, because then I don't want you to think you can't multiply. Yes, I can do that because I didn't lose cosines anywhere. So I multiply both sides, and then I'm going to get cosine squared x equals 2/5. This is the other thing that's going to make my head explode one day. Cosine x equals plus or minus the square root of 2/5. Now, if this was my final answer or it was supposed to be exact, then yeah, I'd need to rationalize, make that look better. I'm about to use the calculator, so I really don't care that it's under there. I'm not going to waste my time or my brain cells fixing that. I'm going to let the calculator handle it all. So at this point, I know that x equals the cosine inverse of plus or minus the square root of 2/5. All right? So cosine is plus or minus. So when I'm thinking around the circle, cosine is either positive or negative in all the quadrants, so I'm going to have to use all 4 of them. And remember, this one is alpha, this one is pi minus alpha, this is pi plus alpha, and this is 2 pi minus alpha. Okay. So the first thing I need to find here is alpha. So in my calculator, I'm going to use the positive version of that. So I'm going to go over here. I'm going to go ahead and clear everything off so I don't use the wrong thing. I'm going to do cosine inverse of the square root of 2 divided by 5, making sure that that 2/5 is all underneath there. Since that's alpha, I'm going to hit enter, and I get 0.886. Okay, so alpha is 0.886, blah, blah, blah. My actual answers here, when I'm done, for x, one of them is alpha, so 0.886 is there. Then I'm going to have to do pi minus alpha, so then I'll have pi minus the answer, not hitting enter. So I get 2.256. Then since I didn't hit enter, I can back out of that and do pi plus the answer and get 4.028. The other thing I like about this is when you use the answer, like it shows you what you're using, so you know that you're like using the right thing. So 4.028. And then my fourth quadrant answer, I can back out of this one more time and get 2 pi minus the answer. And that gives me 5.397. Any questions about any of that? So just make sure you can manipulate correctly and efficiently whatever type of calculator thing you're using. All right, so let's look at number 3. We've got cosine of x equals negative sine x. So cosine and sine, nothing squared, so I'm not doing anything Pythagorean-y. But how else are sine and cosine related? Tangent, beautiful. So I'm going to divide both sides by cosine, so I'll get 4 equals negative 7 sine x over cosine x. Notice how I didn't just jump to tangent, because then it's like, where the heck did tangent come from? So this will become tangent. I'll divide by negative 7, so I get negative 4/7 equals tangent x. So that means that x equals tangent inverse of negative 4/7. And tangent is negative in which quadrants? 2 and 4. Yeah, 2 and 4. All right, so go ahead and on your own find alpha, and then we'll find x. So go ahead and push those buttons and make that happen. Oh, yes, sir. Minus, because think about like if think about the 6 pi 6 thing. If I was at 6 pi 6, I'd back up 1 to get to 5 pi 6. So when I'm here, I have to subtract to get to this one, and I have to add to get to this one. Okay, that's a good question. Anything else? See if you agree with me once you get your numbers. If you're having calculator issues, remember it needs to be in radian mode, not in degree mode. Okay, We good? All right, so one more. I mean, I think you understand the concept here, but this one, we actually get 2 answers. I want to make sure that you know what to do with them. So I have 2 tangent squared beta equals 7 secant beta minus 8. So it would be okay to have mixed trig functions like I did on that side example that I did because we could factor out a GCF, but there's not going to be a GCF here. But I can replace tangent squared with something. That's why we needed our reference chart, right? What can I replace tangent squared with? Secant squared minus 1. Very good. So this is going to be 2 times secant squared beta minus 1 equals 7 secant beta minus 8. So then this gives me 2 secant squared beta minus 2 equals 7 secant beta minus 8. All right, so now everything's in secants. That's good. It's better than having it mixed. So I have a quadratic. I'm going to move everything to the left. So I'm going to get 2 secant squared beta minus 7 secant beta plus 6 equals 0. So now we need to factor. And actually factor. I saw way too many people, like 1 is too many, so way too many people get to something like this, and instead of actually factoring, like so dividing it here and solving this piece and solving this piece, and that makes no sense at all. So got to actually factor this, and there's no GCF to factor out, so I've got to like factor. Most of you would probably do grouping here, which is fine. I'm not going to go through the grouping process. I'm just going to factor it, and I'll just talk you through the old school again, especially since this is a prime number. So one of these would be 2 secant beta. This one will be secant beta. Then I look at this sign. It's positive, so these two have to be the same. This is negative, so they're both minus. My options for these two, my factors of 6, are 1 and 6 and 2 and 3. Well, I know that 1 and 6 makes 7, but guess what? That's not going to work here because I have this 2. If I put 1 or 7 here, or I'm sorry, 1 or 6 here, when I multiply it by the 2, I'm going to get more than 7. So that doesn't work. With my 2 and 3, if I put 3 here, I'm going to get 6, and then there's going to be a 2 here. That's more than 7. But if I put a 2 here, 2 times 2 is 4. My 3 here, that gives me 7. But then I always double check myself. Negative 3 times negative 2 is a positive 6. A negative 4 and a negative 3 gives me a negative 7. I'm factored. Okay? You'd get the same thing by grouping. It would just take longer, and that's why I'm not doing it. Okay, so then I'm going to actually solve these. So I get over here, 2 secant beta equals 3. So secant beta equals 3 halves. Well, I don't have a secant button on my calculator, so I'm going to use cosine, and that makes it 2/3. Okay. Then over here, when I solve this one, I'm going to get secant beta equals 2, and that means that cosine beta equals 1/2. Okay. So I'm going to rewrite both of those over here. I have cosine beta, just because of room, I would imagine you're probably running out of room down there, equals 2/3, and cosine beta equals 1/2. Okay, so both of these, cosine's positive, but I have to do 2 separate things, and these 2 things on my 2 factors may not actually match. But cosine's positive, and I know it's positive here and here. It's positive again, so it's here and here. So that means I should have a total of 4 answers, 2 from each one. Okay. So when I go back over here to solve this, the first thing I want to find is this alpha. So when I do that in my calculator, that is the wrong one. I'm going to do cosine inverse, and I've already forgotten what it was, 2/3. Oh, not that. Okay. Let's try again. Cosine inverse of 2/3. There we go. So I get 0.841, blah, blah, blah. That's my alpha. 0.841, blah, 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 blah. So the actual beta that I get here, I will get 2 of them. I actually have to use my alpha, so 0.841 is the first one. And then the second one would be 2 pi minus that. So I'll do 2 pi minus my answer, and that gives me 5.442. Okay. Then on this one. Okay, so for this one, I'm treating as a totally separate problem from this one, so I need this alpha. Well, guess what? 1/2 is one of the ones you should know. When cosine is 1/2, your angle is not a decimal because this is a special angle. It is pi thirds. So the betas that I get here are my reference angle, which is in the first quadrant, pi thirds. And then what's my fourth quadrant angle? 5 pi thirds, yes. Then I have to give my one answer that has 4 values in it, and they need to be in order from least to greatest. So we're going to think through this. Got beta equals, all right, so I know that I have 2 first quadrant and 2 fourth quadrant angles. I have to decide between these two, and I want you to try and do it without using the calculator. Like, I get that it's in front of you and you could use it and it would be fine, but I want you to be able to reason through things as well. Between 0.841 and pi thirds, which one is smaller? 0.841, because we know that pi is a little bit more than 3, right? When I divide it by 3, this value is a little bit more than 1. So this one is definitely smaller, so it comes first. 0.841, then pi thirds, and then let's think about what we know about the circle. So pi thirds is about right here. 0.841, we don't know exactly where it is, but we know it's before pi thirds when you're rotating. So when I rotate around, and then I have these 2 values in the fourth quadrant, that unit circle is like crazy symmetric. There's tons of crazy symmetry in there. So that means as I go around, I know that the next angle I get to has to be which one? 5 pi thirds, because these are reflections and these are reflections, right? So then I get 5 pi thirds, and then I get 5.442. And when in doubt, divide it out on the calculator. When in doubt, divide it out. Wasn't even trying to be catchy. You can divide it out on the calculator so you can, know for sure. But again, you don't always have that, and sometimes it's quicker just to think, oh, that one has to be bigger, and you're good. Okay. What questions do we have? Anything at all? Okie dokie.